So if you're doing compound interest, this is the general structure for compound interest. Sometimes this is n, but sometimes it's k, so just know those are interchangeable. If you're trying to solve for the variable t, it's in the exponent position, so we're going to need a logarithm to help us with that. So let's say you have these conditions. Okay, so let's take that info and let's plug it in. The amount we have after t number of years, we can find that by, we start with, our initial amount is $1,964.27. And then we said that came from investing $1,000 as our principal. And then we have our rate is 10%, so we're going to make sure to put that as a decimal. 1 plus 0.10 over the compounding rate was quarterly. And remember that k is always the number of times you get to collect interest per year. So quarterly gives us 4. And this is supposed to be k times t up here. And again, t is unknown. So this is what the equation looks like. And any time in math, when your variable is in the exponent position, a logarithm can get it down. So just know, if your variable is stuck in an exponent position, you've got to use a logarithm to get it down. But first, let's do some little simplification. Divide both sides by 1,000. You can do that because this is all one term. There's no plus or minus separating it. It's 1,000. Then there's big parentheses chunked together. So dividing by 1,000 just makes it one number simpler. Okay, now as I was copying that piece down, just notice I did this in my calculator. 1 plus 0.1 over 4. That's 1.025. So t is still stuck in the exponent position. Now that I got the exponent piece by itself, there's no coefficient in front of it. Now I can take a logarithm of both sides. And it doesn't matter what log you take. You can take natural log, log base 10, the common log. You can take log base pi, whatever you want. As long as it's a logarithm, you get to apply the property of logarithms that's important here. We take a log because the old rule is that the log of something, if it's an exponent, the exponent gets to come down and multiply as a coefficient like this. That's natural log, and then all this is still the same. So take a careful look at how that happened. Taking a logarithm of something means the exponent can come down and multiply in front, and so now it's not stuck in an exponent position. Now it's something we can solve with algebra, because all this other stuff are just decimal values we need from our calculator. Okay, so one thing I did in this next step is I just punched this in my calculator, it gave me that. Punch this in my calculator, it gave me that. So my goal is still to get t by itself, and this is 4 times t times this. Order of operations says, your old properties in mathematics say that it doesn't matter which order you multiply things in. So let's do 4 times this. And now, to get t by itself, that's 0.09877 times t. To get t by itself, divide both sides by 0.09877. Okay, so in my calculator, when I divide that, I get roughly 6.848. So just about 7 years, you'll have the money you wanted.